Hello everybody, so today I will talk about calculus. The topic today is about application of integration. So now I will show you how to answer. We want to find the area of the surface generated by revolving the curve y equal to sin x over 3 from 0 to b about x-axis. So now I will show you how to answer. First, we need to find first the derivative of the function. You got about cosine x over 3. Now, we apply the formula of the area of the surface. That should be about the integration from 0 to b. And we will have about 2b y multiplied by the square root of 1 plus first the derivative of y to the power of 2, and we have the x. So we put this one go in here, go in here, and y that's about this one. Next, so we need to put power 2 go in here, and here we have cosine x squared 2 over 9. And then I will put number 9 in here. Number 9 in here. So we do common denominator. So we have 9 plus cosine x squared. The square root of number 9, you got about 3. So we have 1 over 3 in here. So I will put 2b and number 3 and number 3 go outside. So we have 2b over 9. Now we can use about integration by substitution. So I will put about u equal to cosine x du. We have negative sin x ds. After we do first the derivative. Later that we put the negative sign go to the u. Next, we need to change the bounds. When x equal to number 0, so we put number 0 in here, and you got about u equal to number 1. When s equals to b, so we put go in here, you got about u equals to negative number 1. This one we change for number 1. B we change for negative number 1. Cosine x we change for u. So you have u squared. Sin x ds we change by negative du. So with the negative in here, I can swap the top and the bottom together. So the top you got about positive number 1, and the bottom you got about negative number 1. Next, we can use about integration by trigonometric substitution. So I will put about u equal to 3 tan t. Because if we put this one go in here, we have 9 tan t squared. Number 9, we can do about factorization. 1 plus tan t squared, we change secant of t squared, and later that we simplify by the square root. Du, we have 3 secant of t squared dt. Next, we change the bounds. When when u equal to negative number 1, so we put negative number 1 in here. Later that we divide both sides by number 3. So t equals to r tan of negative 1 over 3. When u equals to number 1, so t we have r tan of 1 over 3. So negative number 1, that's about this one. Number 1 in here, that's about this one. U, that is about 3 tan t. Du, that's about this one. So this one we have 9 tan t square. Number 9, we can do about factorization. This one we have secant of t square. The square root of 9 secant of t square, we have 3 secant of t. Number 3, we simplify with number 9 in here. Secant of t with secant of t square, we have secant of t to the power of 3. And now I will show you the technique how to find this integration. So this one I can put about secant of t square multiplied by secant of t. So I need to use about integration by parts. So I will put about u equal to secant of t. So if I will put about z. So if I do first the derivative, we will have about dz equal to secant of t tan t dt. dr, I will put about secant of t square dt. The integration of this one, we have r equal to tan t. So we have z multiplied by r. So that should be about secant of t tan t minus dz multiplied by r. So we have the integration secant of t tan t square dt. Tan t square we change by secant of t square minus 1. And now we will have about 2 integrals in here. The first one you will have, that's about secant of t to the power of 3. And the second one, that's about the integration of secant of t. Negative with negative number 1, that's why you have positive in here. And we know that everything equal to this one. Now I will put this one go to the right. And this one we have 2 because we sum 2 integrals together. Later that we divide both sides by number 2. The integration of this one, we have ln of the absolute value of secant of t plus tan t. And later that we put about c. Now We go back to this one. The integration of this one, that is about this one. And we put the bounds in here. So we put this one going here, and this one going here. And this one going here. We calculate about this one, and this is approximate about 4.27, because the question they just said that 2 decimal place. So this is the final answer. This is the end. Thank you for watching.